xj, v1, v2. Another log record is going to hold ti commit. Another log record is going to hold ti abort. So based on your transaction, these log records will be stored over there. Okay. So that is what basically how you're going to store for your procedure. So whenever the transaction performs a write operation, then the write has to be created before the database has been modified. So once the log record is going to exist, we can output the modification to your database. Okay. So we'll see an example and then we'll be back how this log is going to work out perfectly. So for this, we have two different approaches. One is your deferred database modification. Another one is your immediate database modification. So we'll see with the deferred database modification. Okay. So what is this deferred database modification technique? So this is going to ensure your transaction atomicity by recording all your database modifications in the log. What is the atomicity problem? Either all the transactions should be done or none of the transactions should be done. Antigani, it should not hold any in between actions, isn't it? So either all the operations should be done, what it indicates, you should come across with ti commit log record at the end. No, if none of the actions are done means you should come across with ti abort log record. So this is what is going to happen over here, isn't it? So we'll see over here how to write an example for this. So as you're already aware, these are your transactions T0 and T1. You could see over here in T0, you're reading a value of A and A50 value is getting directed. Then you're going to write A and then you're reading a value of B, and then you're writing adding a value of B, and we are writing B value, isn't it? And you have another transaction known to be of T1, which is going to read the value transaction T0, you're going to transfer from one account to the other account. Yeah, I could hear some noise coming in the middle. So here you could see T0 and T1, we have written two of the transactions. Okay. So right now, if the transactions are executed serially in T0 followed by T1, then how your values are going to come across. For example, if you take A value to be of 1000, B value to be of 2000, and C value to be of 700. So how do I write this particular transactions in deferred database modification using your recovery system? So in log record, you could see over here how to write over here. Okay. So basically, if you see in the first one, T0 start, T0 A950, because in the first transaction, you're deducting 15. So I'm showing you the three possibilities over here. But before you move into the three possibilities, the last one is the final one where you're going to execute your transaction successfully. Okay. So assuming that, which type of operation you're going to use over here, we are going to discuss. So you're going to do only with one operation known to be of redo. Okay. So if you come across with any of the problem, how do I store it over there, right? So you could see in the first case, what's happening? Yes, after the third statement. So this is what I was telling you in the first one. I'm writing T0 start log record. Then in the second one, T0 A950. 950 is what you have done over here. A minus 50. So 1000 minus 50 is 950. Then T0 B 2050. So B plus 50. So 2000 plus 50 is 2050. But after that, the system crashes before the completion of the transactions. Before writing your value of B also. So what has to be written? So the log at the time of the crash is going to run your redo action, so that the values of the accounts of B, A and B, what it will remain. So after this, if there is no commit statement, it will be running an operation known to be of redo. So when you're going to come across with the redo operations, it is going to roll back convert. So if it is going to roll back means what will be the value of A? A will be 1000. B will be 2000. So you're going to go back to the initial state where the actual values were passed. So neither all the operations were done. Okay. In the second situation, we'll see over here. In the second situation, just if after the log record before the step write C, okay, before the write C, you didn't come across with write C and uh, no commit record. So if there is a failure at that particular moment when the system is going to come back up, the operation redo is performed. So once you're going to redo the action performed before T0 commit, you are going to have the values of A and B to be of 950 because you came across with T0 commit. T0 commit means A value has been updated to 950, B value has been updated to 2050. But C value is going to restore to the old value, that is your 700. So after that particular one, okay, you could see that particular one. So it is written into the stable storage. Stable storage means you're not going to update into your database. And finally, you could see the last one, okay, the log at the time of the crash after your T0 commit in the C module. So T1 commit. So if you come across crash after this, so when the system is going to come back, two commit records are there in the log. So one is for T0, another one is for your T1. So therefore, the system is going to perform redo T0 and it is going to redo T1 also. So in which the commit is being done. So it is going to enhance the values perfectly. So A value will be 950, B value will be 2050 and C value will be 600, which indicates all the operations has been done successfully after the system crash failure has occurred. So atomicity and durability, both the properties had been preserved over here. I hope this point is clear over here. By using your deferred data most modifications, if you observe these three areas, the logs at the three different timings, okay. So if you don't come across with three commit, see every record, every what do you say, actions. T0 start is one action, T0 8 950 is one action. All these actions will be stored in your log record. Right now, when you're going to run with your redo operation, it will restart once again. So T0 start, it will search for T0 commit. There is no T0 commit in the first case. So in the first case, what will happen? It will roll back all the values, whatever the operations it has done over there. So it will roll back to the original value. So what is the value of A over there? 1000 and B 2000. So neither of the operations has been done. In the B case, if you come across, it will again do redo from the initial stage until log low, all these actions will be stored. Now when they are going to get removed is after all the actions had been formed, then it will become empty once you finish with your operations. That's the reason when you go to any ATM machine, all the clients, whatever they do the operations, when a client is doing for him, a log record will be created. So whatever the actions he'll be doing, every actions will be stored in that particular log record. So once he finishes with this transaction, that log record contains everything will be cleared off, and it will be ready for the next customer. Okay, so in that way, when to do the recovery of your system is basically done by using your one of your approach, that is your deferred database modification. I hope this example is clear. In deferred database modification, you can do only single operation known to be of redo operation. Redo operation means it will undo the changes of the previous one. So that is what is happening over here in this deferred database modification. So if you see over here in the uh, another modification, we call it to be of your immediate database modification. So second modification is immediate database modifications. So it is going to, I mean, like immediate means immediately when you came across with the database, to send the data to the database if it is still in an active state and matter. Like what will happen is your data modifications, if they are in uncommitted modifications also, they are written. So at that particular moment of the time, it is going to check for the old value and the new value. See, in the deferred database modification, we have done with the new value itself. We didn't use any old value. So I see over here T0, A is your object identifier, 950 is your new value. I used only three variables. But whereas in this immediate database modification, I'm going to use four variables. Four variables means transaction identifier, data item, old value, new value. So immediately at that particular spot of the time, whatever is the new value, that new value will get updated on matter. That is what immediate database modification. So you could see over here the small example how to write for the same operations over there. So you're writing T0 start for the starting transaction. T0 is your transaction identifier. A is your data item. A value is 1000 and B value is some 950. Fine. So similarly, T1 start also you come across over here T1 C 700 and 600. So T1 commit. So you could see immediate database modifications. What could be the scenario if the same failure comes across? Okay, we'll use that immediate database modifications. So you could see over here in the first case what is happening. The so using the log, the system can handle any failure that does not result in the loss of the information and non-voter. So you are going to run two operations. One is your undo operation, other one is your redo operation. So the recovery scheme in immediate database modification uses two recovery procedures. One is your undo, another one is your redo. So undo operation Okay, so undo operations and redo operations. There was a break. I hope it's audible. Don't enable your mic. Just put me a word in your chat box. Is it audible? So we are going to do two recovery procedures. One is your undo operation, other one is your redo operations. Remember, in different database modification, we done only with one recovery procedure, that is redo operation. But over here, we are doing undo and redo. So undo is your updated data items should be restored to your old values, whereas redo items is whatever the updates has been done, you should update to your new values. Okay. So for this things again, like what could be happening in your recovery procedure, you could see the actions over here. Okay. So in the first case, we'll consider the three cases. First, let us assume that the crash occurs just after the log of your transaction T0. Okay. So when the system is going to come back, okay, it is going to find the record T0 start in the log, but no corresponding TI. You don't find out any commit record. So what will happen? The T2 must be undone. So it will go into a undo procedure. What undone means? Undo means undo the operations. Under 950, 2050 will become 1000 and 2000. So as a result of the whole values of A and B will be restored to the old values. Now let us assume that the crash comes after the log record for the step in B case category, right, of C. Okay, so one, the system is going to come back and you're going to do two actions. One is your undo, another one is your redo. Why undo is because TI start appears in the log, but there is no TI T1 commit. So you are not having a T1 commit over there. So for that one, undo operation will be done. And for T0, you're going to run with your redo commit, redo operation. So redo of T0 will be happening for the first three records, because for T0 you have T0 start, you have T0 commit. So for those four log records, you are going to run redo operation. Whereas for the remaining two, you are going to run undo operation. So what will be seeing at the end of your recovery procedure, the values of what will be the values of A, B, and C. A value will be 950. B value will be 2050. What about the C value? C value will be 700 itself. Okay, because you're undoing the operations. Undo means going back to your old value. So finally, we'll come across with the C stage. Okay, if you see the C1, after T1 commit, there is a failure. So once the system comes back, T0 and T1 will be redone. So there is no undo over here. Redone and need to be redone. Okay, so since the records T0 and T1 commits are happening over there. Okay, so I hope this problem is clear. Immediate database modification. Remember, in deferred database modification, once if any failure comes and if the system is going to recover the system, once the starting procedure restarts once again, there is a probability of fully redoing the operation once it sees the commit, start record and the commit record. In immediate database modification, you are going to classify whether the action should be undone or redone. So for two procedures, undo operation and redo operations. Undo operations is if any of the log records are moving into a failure state, those will be moving into an undo operations, and those who already came across with your start and commit records will be moving into a redo phase. So two operations are reliable because for immediate database modification. Okay. So this enhances that which particular procedure is applicable for which type of application. So this log recovery procedure tells you that, okay. But when we are talking about this redo and undo, it's very easy to tell you in this particular part wherever the log records are coming. These are all the log records, isn't it? This is what the program will be written for your log based recovery systems, okay. The log records, see how many log records you have in first one, three log records. In the second case, how many log records you have? 1, 2, 3, 4, 5, 6 log records. In the third case, how many log records you're having over here? 7 log records, isn't it? So as the operations or transaction size increases, the number of the log records also gets increases, isn't it? Because every step, whatever you do on the machine is a log record, okay? So recovery cheyali ante without the information getting lost, these things will be stored in your log records stable for some time. Okay. So right now we are telling that way to do this particular part, whether undo or redo operations. That is the reason we'll apply some checkpointing concept. Okay, so we'll see this checkpointing concept for how do you identify this? I'll tell you with an example, the checkpoint concept. Okay. So if you can observe this diagram carefully over here, how many transactions am I using over here? Four transactions, isn't it? So what are those four transactions? T2, T3, T4, something like that. So if you see the first transaction, I'm going to put two of the um, uh, points. One is your checkpoint. Another one where we don't know whether log records are coming or not. So that is the back. Okay. So in the first case, before checkpoint, the transaction has been successfully completed. So what do you mean by that? Neither the redo operation, neither the undo operation takes place because there is no probability of your checkpoint, right? But whereas in the second case, if you see, uh, second transaction. In the second transaction, it started before your checkpoint and it is ended before the failure. So that particular transaction will be, once your system comes across with your failure, the system is going to move this particular transaction into a redo phase. So redo means it will, whatever the changes you have done up till, because the commit has been done, so you're ending the transaction. What it indicates, the transaction has been successfully completed, but after completion only there was a failure. So if there is a failure after the completion, whatever the values you have changed, all those values will get updated. Similarly, you see with the third transaction came across after the checkpoint but ended before your transaction failure. So this also is going to come across with your redo. And the final one, if you see the last one, system failure, the transaction started, but it hasn't ended. Meanwhile, there was a system failure. So this type of transaction should move into your undo phase. And then neither of the operations, whatever you've done up till now, should not take place. Okay. So in this way, if any transaction is given to the system, the uh, system is going to do this, it's going to apply this checkpointing technology. Okay. So all these transactions will be running majorly through this checkpointing theme. Okay. So this checkpointing is going to analyze whether to go of undo operation, whether to go with the redo operation. Okay, that is what with your checkpointing concept, because we are using the operations and undo and redo operations, we should have an awareness where this actually the transaction is going to fall under this particular category of undo and redo operations. Okay, I hope this concept is clear with your checkpointing. So we learned with the log-based recovery, one scheme where you need to run in two procedures. One is your deferred database modification. Another one is your immediate database modification. Deferred data modification can be executed by using only a single operation known to be of redo operation. And you're not going to have your old values in deferred database modification. Whereas in immediate database modification, you are going to store old value as well as new value. And immediately after the log record has been executed, immediately there is a change of the value in the record. That is what immediate is. So immediate database modification could be executed by two operations, recovery operations. One is your undo operation, other one is your redo operation. So how could you identify which transactions fall into the category of undo operations and redo operations? There is where we come across with the checkpointing concept. What is the checkpointing? So now there is a probability of the transactions moving. So if any transactions that have committed after your commit statement, but before to your failure, will be moving into your redo operation stage. But if any transaction started and if it isn't completed any commit of the transaction, then obviously it is going to move into the undo operation stage. So in this way, you're going to identify which of the transactions fall into the category of redo operations and undo operations. So this is clear with your log-based recovery. Okay. So now, as we are aware that recovery with your concurrency control, that is your concurrent transactions. So what could be done over here? Same thing over here. I mean, the concepts will get repeated because undo of the operations will be done in your strict two-phase locking protocols. If it is used for the strict, we have done with the various protocols, right? It's your two-phase locking protocol or Hello. Fine. Somewhere in the middle might be the net has been disconnected. Sorry for the inconvenience. We'll carry on. Fine. So recovery with concurrent transactions you can do by using your different same checkpointing concepts, your restart recovery. Anyways, whenever you go with your restart recovery, you should check for this undo operations, redo operations, and your checkpointing concept. Okay, whether to roll back or whether to proceed. Uh, so you see an example over here. What's happening in uh, this particular one? See. The steps of the recovery algorithm. Right, fine. For example, scan the step. See, the scanning will be done over here. Every time it will check for this start and the commit button. You could see over here T0 start. It has been committed. Then again T1 started. Eh, but T1 hasn't been committed, but T2 started. After T2, there is a checkpoint for T1 and T2. Then T3 started. Then you have T3 commit. So during this particular transactions, if any of the failure arises, so if you see T0 is the safest one because neither undo operation, neither redo operation because T0 has been committed. But whereas you come across with T1 start, T2 start, you have a checkpoint over there for that, isn't it? Right now, if there is a failure after this checkpoint or no commit statements at all, T3 commit you have come across. Where is T1 commit? Where is T2 commit? We are missing this T1 commit and T2 commit. So after this, if T3 commits, we should have the probability of identifying which particular log record will be moving into an undo operation, which log record will be moving into a redo operation. So if you see T2C010, okay, T3C1020. So if you come across with those values over there, you could see whether this particular values are getting updated or not. So undo operation, redo operation. Undo operation will be done for T1 and T2. T3 key redo operation will take place. Okay, so in this way, you're going to recover the process. So if the actions are not undone, what you're going to do? You're going to restore to the old value. Old values means the database is in a consistent state, right? See, either all should be executed or none of them should be executed. If you're doing undo operations, none of them will get executed. If you're going to do redo operations, we are going to execute few of them. And you could check that all the those values of that particular transactions had been updated. So this is what is your uh, I mean like log-based buffering. So we'll see the buffer management. Okay. So in I mean like so to implement a crash recovery scheme that ensures your data consistency and checks whether a minimal amount of overhead on interactions within the database. So we could see that we'll be having log record buffering, you'll be having a database buffering, different types of the bufferings. Okay, log record buffering. So what is this buffering? Buffering means a temporary storage. Okay, so we have assumed that every log record where we are going to write it into your stable output stable storage at the time whenever it is created, isn't it? That is what we have assumed. So now this assumption, what it's going to do, it is going to impose a very overhead on the system executions for several reasons. Like for example, in most cases, a log record is much smaller than your block. Log size ఎక్కువ, your log record is smaller. Then what will happen? This particular output of each log, it's going to transfer into your larger output at your physical level, and the smaller ones will be combined together on matter. So this is all for your log buffering, how to reside in your main memory for a considerable amount of the time before it is output to your stable storage. So since if any log records are lost. If the system crashes, we can use this additional requirements on the recovery techniques to ensure your transaction atomicity. Okay. So, you need to do this, the rules one by one. Until when transaction TI enters the commit state, that is after TI commit, the log record should be written to your stable storage. Fine. It should be written to your stable storage. So before the TI commits, the log record can be output to the stable storage also. I mean, it is um, input storage, output storage. I hope you know what you mean by that. Okay, to and fro changes for your main memory. So before a block of the data in the main memory you could see can be output to your database. I mean, like write ahead logging protocol, we call it as strictly this rule. We call it as all log records pertaining to that particular data in that block must have been written to your stable output storage. Forcefully, you're going to write over here, okay? And the operation is going to get executed. So we call that particular one to be of WAL, write ahead logging protocol. So you could see over here, logging, right ahead logging, this rule. What is that rule? Before the block of the data, if you run these three rules, and these three rules are implicated, we call this to be of a write ahead logging. So in order to reduce your overhead of your storage system, should not increase, right? So log records, when you're going to write to your stable storage, in whichever way they are created, you're going to output your stable storage. So once it comes across with the commit state, when the log record TI commit, then only it has to be output to your stable storage. So before the block of the data in the main memory is output to your database, all log records in that particular block must be have been written to your stable storage. So now once the complete set is clear, it indicates that it is stored, isn't it? Your output has been written earlier. That is what write ahead logging. So if there are no concurrences or the same component, the same log record will be outputted to your log component. Okay. Whereas database buffering is different. If you see the database buffering, in the database buffering, you are going to output your log records to your until all the log records you could see over here until all the records pertaining to that particular block has an output, like output block to your disk or input block from disk to your main memory. So if you for example, we can ensure that there are no writes in the programs by using a special means of your locking systems, database buffering, log record buffering, database buffering. Remember over here, we are talking about the log component. Over here, after it is written to your stable output stage in your log record buffering, it should be written to your database. Directly, I cannot write all the components to your database, isn't it? So before to that, some certain temporary location I'm going to create over here, which is known to be of buffer. So I'll do all the executions, I'll output onto the disks and I'll check it out. And then finally only I'm going to make a right inputs to your database storage system. So that is what is your database buffering. Like see, for example, let me examples over here from English. If you see in your OS, I don't have the diagram actually over here. I will tell you over here. Okay. So what's happened over here? What is going to happen over here is, for example, see, whenever I make a request into the system, okay, that request should be identified by my database, isn't it? So directly, I should not move every request, whatever it comes to me, into your database. The request has to go that request has to go into your log-based buffering anamata. There is a pages, frames concept, isn't it? So in the disk, you'll be having n number of pages. So that request will go into that particular page. In that particular page, it will check that whether the page is free or not. If the page is free, whatever request I make will be moved into that particular page. Okay. So in that particular page, I'll store all my log records. I will compute, and then if everything has been resolved at that particular term, then finally I'm going to make it to your database change. That is what database and log-based buffering is. But if there is no space in that particular disk management, where should I store it? That's the reason over here it has to do the dual paging concept anamata. Ante if that page is already being used by some other user, and it will check for the number of the times that the user has used that particular page. So the count will be notified. So suppose if the client is not using regularly, that particular page will be the contents in that particular page will be removed, will be erased, and making that page to be of empty. So whatever request now I make will be moving into the particular page. I'm going to do all the modifications in the using that log record buffering, and then finally I'll move it into my database buffering. This is what is the overall theme of your buffer management, how to manage the storage space on your disk. And every time I cannot directly deploy my updated statements in my database disks. So earlier in my log buffering, I should modify all the tasks, and final operation should be written onto my database disk. That is what is your functionality of buffer management. Okay. So you should see what is the major role of your operating system. That is majorly plays a role in seeing about the space management systems. Okay. So then we'll go on with your advanced recovery techniques. So in this advanced recovery techniques, we do have one of the algorithm known to be of Aries. See, you'll be using the same concepts, but you now had this theme of writing the log records. Run. Good. Now, using those log records, you should run the algorithm. Okay. What is that algorithm? How to exploit? Okay. So, like this advanced recovery, and to increase the concurrency, we'll be using your V plus trees algorithm. And similarly, alternate recovery techniques for uh, how to release your logs. All these things will be of advanced, but for recovery scheme, we have an algorithm known to be of Aries. Aries recovery scheme, which is widely used in the industry. And it is very complex that are and it is very advanced. Okay, so what it is going to do is it is going to incorporate a number of optimizations to minimize your recovery time and provide a number of features. Okay, so we'll see how to minimize this recovery time. Okay, for this particular one, we'll be running an algorithm. What is Aries? Uh, Aries. So Aries is an algorithm for recovering isolation and exploiting semantics. Let me hope I can't write over there. Yes, what it is, algorithm for recovery, isolation, algorithm for recovery. I should do recovery. I should satisfy the property of isolation and exploiting semantics. Exploiting semantics. Aries, A for algorithm, R for recovery, I for isolation, and E for exploiting semantics. Okay. So once this algorithm is run on any machine, now you prepared your log records. The log records are there in each and every components. Now this log records should be executed. So to execute those log records, we'll be running this algorithm. That is your Aries. So we'll see how this Aries algorithm is going to take place. Okay. So uh, this can please check one. So this particular one is going to run in three phases. Okay. So when I'm going to start, for example, how to tell you. So when the system comes across with the crash, you need to recover it. So what you're going to do, you're going to recover, means automatically the system could be on, or you have removed the bug, whatever you came across. So once you come across with that Aries recovers from the system crash like in three phases. Okay, one is your analysis phase, another one is your redo phase, another one is your undo phase. Analysis phase until first thing it will run into this phase, this algorithm is okay. So what it will do in this phase is analysis phase. It finds the last complete checkpoint log record and reads in the dirty page table. So you'll be having a dirty page table from this record. So it then it's going to, I mean, you have all the records, kada, and in the all those records, it will identify those log records which haven't completed the transactions. So those log records will be moved into your dirty page table. So if there are no dirty pages, it sets redo operations, redo log sequence number. If there are any dirty pages over there, okay, it is going to do the undo list. Okay, so in this particular one, what it will do is the analysis pass continues scanning forward from the checkpoint and the checkpoint better. From there, it start scanning. So whenever it finds a log record for that particular transaction, not in the undo list, it adds the transaction to the undo list. When it finds a transaction at the end log record, it deletes the transactions from undo list. So all transactions will be left at the analysis and will be rolled back. I'll take an example and I will see over here. What is the dirty page table? What is the buffer pool? What is the page log sequence numbers on the disk? See everything. If you are clear with your operating system pages concept, this is what the actions we are going to take place. Okay. So now P1, P6, P23, P15 are there in the buffer pool. Okay. P1, P6, P23. The previous log sequence number, the record log sequence, page log sequence number, the record log sequence number will be noted in your data page, dirty pages tables. Okay. So now once the transaction starts, the first one is your P1, page one. Okay. So in that page one, I'm coming across with the log sequence number 25 and your record log sequence number 17. So it is going to pass down, right? So when it's going to pass down each and every action, you didn't come across with any commit statement. So meanwhile, it will be in the undo list itself. When it is going to go with the redo list, yes, once you come across with the commit statement at the last, then it is going to move into your redo list. So until then, it will be in the dirty pages tables. See, remember, if you have completed all your, say, P1 2517, the transaction has been successfully completed. You came across with P1 committed. So once you come across with P1 committed, what it indicates over there, the transaction has been successfully committed. So it won't move into your undo list. It will move into your redo list. Okay. You should do analyzing. Okay. Pages that are there on your disk, all these pages should be analyzed. So in the analysis phase, it is going to identify which pages should be moving into an undo list, which pages should be moving into a redo list. That is what the analysis pass will be coming across. So in the redo pass, what you're going to come across, the redo pass is going to repeat the history. What it will do, redo passes every action which is reflected in the page on the disk. Okay, so it is going to go forward it is going to find the update log record, and then from if it is not there in the dirty page table, then the update log record will be set to your redo pass, and it's going to skip this log record. If it is there from the dirty page table, it is going to fetch that particular page from the disk. And if the page log sequence number is less than your log sequence number of your log record, it redoes the log record. Otherwise, it's not going to redo. Okay. So if this test is positive or negative, if it is negative means it is going to roll back. If it is positive means it is going to the values and it's going to move further away from the page to the disk. Undo pass will be rolled back. So the undo is just straightforward one. Okay, it is going to do backward scan operation. Undo all the transactions in the undo list. If the clear is found, it uses the undo next log sequence field. Okay, so whenever an update log record is used to perform during the restore. Okay, so the undo pass, it's going to generate a CLR, anti clear, containing the undo actions. So using these three phases, it is going to identify which pages. See, in the earlier one, we were talking about the checkpointing, which transaction should move into an undo phase, which transaction should move into a redo phase, right? Right now, when we come across an Aries algorithm, the same thing, depth analysis will be done over here. When you're going to recover from a system crash, it is going, every log sequence number, log sequence record will be entering into the analysis pass. Analysis phase ఏం చేస్తుంది? It should identify which pages should move into the dirty page table, which pages should move into your uh, database table. Okay. So if there is any failure, everything should be passed through your dirty page table itself. So initially, because you're not going to come across with the commit statement, all the pages will be stored in your dirty page table. So once again, if the log record comes across with the commit statement, then those particular logs records will be moved into your undo phase or redo phase. This is how the operation is going to take place in your Aries recovery algorithm. So it's going to recover all the log sequence records that are present in the log buffer. Okay. So see, it's very easy. Once the identification is very easy, which particular data item should be redone, which particular transaction should be redone, then based on that, the ADS algorithm is going to execute all these operations, redo operations and undo operations. So now this is going, because of this Aries now recovery independence, everything is of your it's going to come across with independency. What is independency? If some of the pages of the disk fail, they can be recovered without stopping the transactions of the remaining pages, because in the dirty page table you're coming across with only the failed pages, so the failed pages will be recovered. Meanwhile, whatever the other log records you have, those records can continue with the process. That's the reason we call it as recovery independence. And similarly, you can find out another feature which is very reliable with the algorithm is your save points. Okay, so it is going to save point and roll back to your save point. That is what we have done now using your save points concepts. Ante immediately if I do, that is what immediate database modification is. If I do immediately, it is roll back. But if I do between save point and roll back, then it will be of a deferred one. Okay. So that same thing is getting implemented in my Aries recovery algorithm. Okay. So one of the procedure over here is Aries recovery algorithm. That is what I was explaining over here. You could see this recovery algorithm, analysis phase, redo phase, and undo phase. Okay. Which transactions to undo, which pages should move into your data page table, dirty page table at the time of the crash, and which has to come across with your redo pass and your undo pass. Whether you're going to repeat the history for redo pass, reading all the actions from the redo log sequence number, and then undo pass, it's going to roll back all incomplete transactions. So if you see the key idea, no need to undo all these transactions. Earlier, undo actions were locked, and if the redo as, so I hope these three passes are very clear. Okay. Aries algorithm, you should be very clear. You'll be writing your log records. Every action is of a log record. All those log records will be stored over there, isn't it? So all those log records require an algorithm to take off. What is that algorithm? It is a Redis algorithm recovery for isolation exploiting semantics. So you should satisfy all these characteristics. Okay, so your how do you satisfy is you run those algorithm in three phases: analysis phase, redo phase, and your undo phase. Analysis phase, which log record should move into your dirty page table, into undo page table, and redo page table. So once this classification is done, you are going to do undo and redo operations. Meanwhile, in the dirty page table, which were inactive, that one will be recovered, and then they'll be moving into the redo phase and the undo phase. Okay, just very clear about your Aries recovery algorithm. That is what you're going to come across with your Aries recovery algorithm. Okay, so you can take up with your examples and work out for your. So remember, this Aries algorithm is a state-of-the-art recovery algorithm. Okay, it is going to have a variety of optimizations designed to improve concurrency, reduce logging overhead, and reduce your recovery time. It's going to optimize while designing to improve your concurrency, right? To reduce logging, reduce overhead, and reduce your recovery time. Recovery time, see, earlier days, if there is any failure of the system, they were taking weeks and weeks, or if any transaction failure has happened during your a good example, while doing the reservation itself, you have reserved and you have paid, but your reservation hasn't been done, isn't it? How do I recover that? See, you can take up your live application of that. How do we recover that particular one? Immediately, if it hasn't been booked, okay, you'll get a message saying that the amount will be recovered within 15 days or within 2 or 3 days. This is what is the recovery process. So within those 15 days, they'll identify what is your um, I mean, where did the process stop? What is the value has given over there, isn't it? So that will be restored back to its original position. That is where you can apply this algorithm. So any true applications you'll be running with your Aries recovery algorithm directly. You cannot do anything on your database disks. That's the reason you'll be having your log-based buffering and do all those logics in your log-based buffering, and then only permanent changes will be done into your database modification technique. Okay. Right now, we'll come across with your remote backup systems. So, I mean, like recovery part, see, one thing is any type of the failure, we should not leave our system in an inconsistency state, isn't it? You should recover your system. Recovery should be done to your system without losing any information. So for that reason, we are learning various techniques and algorithms. So we applied log-based for log-based recovery. We have an algorithm over there. So these two together, we can remove the process of we can remove the concept of inconsistency. And the operations are wholly being done or none of them being done. If anything happens in the middle, how could I recover that particular process? For these things only we learned with the two of the procedures. Okay. So finally, we'll come across with the remote backup systems. Okay. Like for example, traditionally, we know that your transaction processing systems are centralized or client server systems. Fine. But those systems, they are vulnerable, vulnerable to their disasters like fire, flooding, natural disasters, right? So earthquakes. So there is a need for this transaction processing systems that can function in spite of your system failures regarding your environmental disasters. So to provide such an high availability, the time for which the system is unusable must be extremely small, right? So we can achieve this availability by performing your transactions processing at one site called the primary site. So you could see over here, remote backup systems provide high availability by allowing your transactions processing to continue even if the primary site has been destroyed. So you could see I'm having a remote backup where all the data from the primary sites are replicated. I'll call this also to be of a shadow paging technique, right? Because primary log records, all the data has been backed up over there. Fine. So the remote site must be kept synchronized with the primary site. Mm, I mean, updates are performed because the updates will be done only at the primary sites. If you synchronize from your primary site to your remote backup site. So every time you should see how this is how the, so when the primary site is going to fail, the remote backup system takes over the processing. So it performs recovery using its copy of the data from the primary and the log records received from the primary. So in this effect, the remote site is performing your recovery actions. Okay. So once the recovery has been performed, the remote backups starts processing your transactions. Very clean idea. If the primary site is going to fail, the backup gets initiated. It makes until it never shows that this application has been failed. You're going to continue with the process. Meanwhile, your primary site will get updated or recovered, and all whatever has been done on your backup will be restored back to your, that's the reason we need to synchronize with your primary site, so it will be restored. So the performance of your remote backup system is better than your distributed systems with two-phase commit. Okay, so you can design see over here, your detection of several issues can be addressed while designing this backup systems. Detection of a failure. Okay, so if there is a failure of the communication lines or remote back, using this backup, what will happen is if there is a failure also, because you have your backup, that will be restored by the different remote sites backup, isn't it? So who can communicate over with your through your telephone system. Similarly, transfer of control. So when the primary fails, the backup site takes over the processing and becomes the new primary. So when the original primary site recovers, it can either play the role of the remote backup or can take up the recovery site again. Okay. So transfer of control could be done over here, isn't it? That's the reason. See, in the backup now, if this primary is going to fail, the backup will become the primary. Okay. Next time, once this primary has been recovered, the primary could be of the backup. This backup will become the primary. It's left to us the way we decide. Okay, the simplest way of transferring your control. Okay, time to recovery also. So using this remote backup system, the recovery process grows large. Recovery will be, takes a lot of time. So periodically, you need to have a hot spare configuration. Um, I mean, like again, it should be ready for your new transactions. The time it takes to recover, perform the checkpoint, and you should see whether the log should be undo, whether the log should be redo. So over a significant amount of the time it takes to recover. Okay. Next, time to commit. So in time to commit, we'll be having one safe and two safe. Okay. So I think one safe, two very safe, and two safe. So to ensure that the updates of your complete transactions are very durable, okay, uh, the transaction should not have a declared complete statement. So if you see in the one safe, a transaction commits as soon as the commit log record is written to stable storage at the primary state, one safe that is. The problem with the scheme is what will happen is we have not made it to your backup set. So when the backup set takes over the processing time, whatever the updates you have done over here will be lost on one safe. Two very safe is uh, two very safe is like the transaction is going to commit as soon as it is written to the stable storage at the primary and the backup site. Okay, so this is going to, and the problem with the scheme is that the transaction processing cannot proceed if either of the primary or backup site is going to is down. So the availability is actually less than when compared to a single site case. Okay, when you come across with two safe scheme, this is going to proceed like as a two very safe if both primary and backup sites are active. If only the primary is active, the transaction is allowed to commit as soon as the commit log record you're going to write to your stable storage system. So this scheme is going to provide better availability than two very safe matter. So while avoiding the problem of the last transactions faced by the one safe scheme. So it results in a slower commit, better availability is in this very okay. There are a number of the ways where you can do this remote backup systems, okay, but you should check for this one safe, two very safe, and two safe, whether to uh, commit a log record. I mean, like if as soon as a commit log record is written at the primary site, because you haven't done at the backup, it will updates may not arrive at backup before it is left over with the problem. Whereas two very safe at both the sites, primary and backup will be updated. But if either of the fails, you cannot commit if either site fails. The two safe is both are active. Primary and backup are active. If primary is active, the transaction commits as soon as your commit log record is written at the primary. So there is a possibility of using your RAID systems also. Mirroring, we call it as self-stripping, mirroring. Mirroring, you know that it's exact the same copy of our face. Okay, so if you have a database, the exact copy of the database will be replicated on the database disk. So if you do any modifications on one end also, it is going to change on the other end. So if the primary site is going to fail, whatever has been written on the disk will be copied down to your primary site. So there are n number of ways of recovering. Only the thing is we should check over here is the optimization. Whether I can achieve high availability with less cost efficiency. So in that way, your remote backup systems are applied. Okay, so remote backup systems. So remote backup systems for storing the entire part. The replication process could be done by using your remote backup systems. Okay, so in any ways, you're going to recover the process. Fine. So this is with what about your recovery systems. So these are all your examples you came across. So right now, let me give you the overall theme what we have discussed today. Like if any computer system is subjected to failure, like we have different types of the failure, software failures, error failures, everything. So in each information, the database information is lost, isn't it? So how to protect without getting this information lost? Okay, so for that reason, we have done with the various recovery techniques, approaches. One is your log-based schemes, another one is your shadow paging. Okay, we're done with the log page scheme. So if you see with the log page schemes, what it is going to do, which must be kept in a stable storage. So you have a deferred database modification scheme, you have an immediate modification scheme. So during your deferred modification scheme, during the execution of the transactions, all the write operations are deferred until the transaction is partially committing. Okay, so in the immediate database modification, the system applies updates directly to the database. So if the crash occurs, the system uses the information, the log, for restoring to the original database data. So we have done. So to reduce the overhead of searching the log and routing the transactions, we can use the checkpointing technique. So we have applied the checkpointing. So whenever the transactions are running, you can easily analyze which transaction is in which phase, undo phase or redo phase or uh, undo phase or redo phase. Okay. So to recover from the failures also, we have run with an advanced recovery techniques, which is known to be of Aries recovery algorithm. So in Aries algorithm, you're going to run three phases: analysis phase, redo phase, and your undo phase. So it is going to support features like to provide greater concurrency, reducing logging overheads, and minimizing your recovery time. So it is also based on repeating of the history and doing undo operations. Okay. So Aries uses completely your log sequence numbers to implement your optimizations that can reduce the time taken for the recovery. And finally, we dealt with remote backup systems to provide a high degree of availability, allowing your transactions to continue even if the primary site is destroyed by the natural disasters. Okay, so this is the overall theme of your log recovery. So now, if the content has been recovered, okay, in spite of any failures, your database is in a safe mode. Okay, once it is in safe mode, I should use my data structures to store in my pages. So for that reason, we'll go with the file organization and indexing part. So this file organization indexing is the last part of your unit 5. So if you want me to continue, I'll continue. Otherwise, we'll take up a break and be back by 12 o'clock, 12 to 12:30 or 12 to 1. We'll have a file organization where I can finish that also. I'll take another 1 more hour. If not, we'll continue on Wednesday first hour. Yes. Can I know if anyone is there in an active state? We'll continue on Wednesday, ma'am. We will continue on Wednesday. Okay, sure. So we left with a very small concept, file organization. So 1 hour will be sufficient. We can end up. Fine. Okay. Okay. Thank you, ma. Okay, we'll continue on Wednesday, the remaining part. Thank you for your smile. Okay.